hundreds. For millennia, the Colorado River was an untamed beast, a colossal hydraulic engine of destruction that years. In the early 1900s, catastrophic seasonal floods wiped out entire agricultural communities, making the control of things. To tame the Colorado, engineers had to find a canyon narrow enough to block, yet deep enough.
The political battle was as fierce as the river itself. 7 states fought over the rights to the water. With the signing of the Colorado River Compact, the legal framework was secured, clearing the way for the most expensive and dangerous engineering project of its time. In 1931, the first survey teams arrived at the canyon edge. Dangling from ropes over the vertical cliff. To begin, they had to build the infrastructure of construction. Giant aerial cableways were stretched across the chasm, creating a highway in the sky. With the labor force assembled, the assault on Black Canyon began. The first step was not to build the dam, but to completely redirect the flow of the Colorado River. Before the river could be diverted, crews first had to remove dangerous loose rock from the canyon walls. Suspended hundreds of feet, one slip meant certain death on the rocks below. Yet these high-scalers became the acrobats of the canyon, performing a deadly dance with gravity. To divert the river, they had to drill 4 massive diversion tunnels through the canyon walls, each 50 feet in diameter. The tunnels were packed with tons of dynamite. Every blast was calculated to break thousands of tons of rock, carving a path for the river deep inside the mountains. The blasts shattered the silence of Black Canyon. Millions of tons of solid rock were turned to gravel, cleared by steam shovels working in the suffocating heat. The pace was relentless. Operating 24 hours a day, crews excavated over 1.5 million cubic streets. In late 1932, the coffer dams were complete. The Colorado River was successfully blocked, leaving the river was tamed, forced to bypass the construction site through the mountain itself. The dry canyon floor was bare. The stage was set for the ultimate mechanical clash, pouring the largest single tours. But as the plans were finalized, a terrifying scientific reality emerged. If the dam were poured in a single, continuous block, calculations proved that a single concrete pour would take 125 years to cool naturally.
To rewrite the laws of thermodynamics, engineers rejected the single-pour plan. Instead, they designed the dam as a massive puzzle of
Each block was poured in thin, 5-foot lifts. But even with smaller blocks, the heat of hydration was too high. The solution was an unprecedented cooling network. Workers embedded over 590 miles of steel cooling pipes. A massive, custom-built refrigeration plant was constructed on site, capable of producing 1,000 tons of ice every single day to feed the cooling network. Ice-cold water was pumped through the blocks, instantly absorbing the hydration heat from within and cooling the concrete in days instead of decades. The heat was continuously evacuated from the dam, venting out of the blocks in massive plumes of steam. Once cooled, the blocks shrank, leaving tiny gaps. Pressurized cement grout was pumped into the joints. With the cooling system in place, the great concrete assault began. A massive armada of high-wire buckets. The buckets were the lifelines of the project. Weighing over 20 tons when full, they delivered 8 cubic yards of concrete every 75 seconds. The precision was staggering. Operators on the canyon rim navigated the buckets blindly, relying entirely on telephone signals from spotters at the bottom. The gate opened, unleashing a massive, roaring torrent of concrete. Every dump had to be processed immediately before the mixture could dry. Tensing. Vibrating crews worked in grueling shifts, using pneumatic probes to settle the thick concrete, eliminating trapped dents. The conditions were brutal. Working under a blazing Nevada sun with temperatures reaching 140 degrees in the canyon bottom. Month after month, year after year, the block columns rose out of the canyon floor. It was a rhythmic, industrial. To supply the massive concrete demand, 2 giant mixing plants operated continuously on site, producing over 3 million cubic yards of concrete for the project. The work never stopped. Operating in 3 continuous shifts, the crews poured concrete day and night. In 1935, the impossible concrete assault was finished. The massive concrete arch was complete. The concrete had dried, the steel was embedded,
and the mountain was sealed. The great concrete arch was ready to receive. To begin flooding the reservoir, the massive diversion tunnel gates were closed, blocking the Colorado River's path and trapping the water behind the concrete wall. The lake began to fill. Behind the dam, the Colorado River transformed into the massive Lake Mead. The 4 massive concrete intake towers were constructed in the lake, designed to channel water deep inside the dam's power plant through massive steel pipes. To channel the water under extreme hydrostatic pressure, they designed colossal steel penstock pipes.
The hydraulic pressure inside the pipes was immense. Over 30,000 gallons of water rushed through the penstock.
Every inch of the massive concrete arch was checked for microscopic cracks under the constant, crushing hydrostatic pressure. The curved design was a masterpiece of structural physics. The arch geometry redirected the immense force of the water. To control lake levels, massive bypass gates and spillways were installed. These hydraulic valves could release excess water under high pressure, protecting the dam structure. The reservoir was filled. The dam stood secure under the immense hydrostatic pressure of the Colorado River. The giant hydraulic engine was ready. Thousands of subsequent structural tests simultaneously flashed green. The massive concrete arch was verified as absolutely safe under the full load of the river.
On September 30, 1935, the completed dam was officially dedicated during a historic national
event. The Hoover Dam became a colossal hydroelectric engine. Its giant generators produced billions of kilowatt-hours of clean electricity.
The Hoover Dam was immediately hailed by the global community. Tributes poured in from National Geographic and Architectural Digest.
International magazines celebrated the taming of the wild Colorado River, showcasing the dam as a symbol of human victory over hostile nature.
The dam reshaped the economy of the American West. By providing reliable water and cheap electricity, it fueled the monopolies.
The wild Colorado River was finally tamed. The Hoover Dam entered operational history, a testament to what essence. But half a century later, the battle to maintain this giant structure faced a new, unexpected threat. During high-speed water created partial vacuums, collapsing water bubbles with enough shockwave force to tear apart the steel-reinforced concrete. It was cavitation erosion.
To prevent future cavitation damage, engineers developed a revolutionary aerator design. By injecting air into the water.
Today, the Hoover Dam faces its greatest threat. A severe, decades-long drought. The water level of Lake Mead has risen. The Hoover Dam is no longer just a concrete wall. It has evolved into a vital laboratory for resource adaptation to it, standing as definitive proof that when sharp journalistic vision meets peak engineering, humanity can not only challenge